Hey guys, how's it going? In this video, I'm going to go through this Leetcode 234 Palindrome linked list. This is an easy problem and was asked by Facebook for 16 times in the past 6 months, also Amazon, Microsoft, Google, and PayPal. Let's take a look at it. So we are given a head of a singly linked list. Return true if this is a palindrome. Let's look at an example. 1, 2, 2, 1. This is this is a palindrome, so return the true. And 1 to 2, this is not a palindrome, so it returns a false. And also there's some constraint, the numbers between 1 and 10 to the power 5, also the number of nodes, right? Oh, sorry, the number of nodes will be anywhere from 1 to 10 to the power 5, the number between 0 and 9, inclusively. And also there's a follow-up, can you solve it with a big O N, runtime and big O1 space? And this is exactly what we're going to do. I think this is a pretty good question because it touches a few points of commonly used in linked list. Let's dive in. So let's take a look at an example, okay? And let me zoom in a little bit. So let's say this is the palindrome we're looking at. 1, 2, 2, 1. This is exactly that. Okay, so how can we check if that's a palindrome or not? So first thing, we have to break the palindrome into two halves, right? In order to compare it. So the way to break it is to have use the two pointers method, which is a very common method in linked list. So we have a fast pointer and slow pointer. When the fast pointer moves 2 steps at a time, and the slow pointer moves 1 step at a time. So when the fast pointer hits none, which is at the end, the slow pointer will be exactly at the middle. So in this case, so the fast pointer will be at the none, and the slow pointer will be in here, the 2. Okay, so this is how we can separate the linked list into two halves. And right now, after we separate it, we have to reverse the second half. Okay, so this is another commonly used method to solve linked list problems. So after we reverse it, becomes 1 to 2. And now we have 1 to 2 for the first half, and the second half is also 1 to 2. We just compare them. If the element of the first half is exactly the same as element of the second half, we are done. So this will be a linked list. Otherwise, it's not a linked list. So this example is on the even length, and it's very similar for the odd length. The code is transferable. So anyway, I'm going to dive into the code. As always, linked list is easier to say than done. And at this point, feel free to just pause the video and try to solve and implement what we just discussed in here. And now I'm going to dive in. So first, we want to use the two pointer method. I highly recommend people keep saying like don't memorize the code, but this is pretty standard template, so it's up to you. So we have the fast and slow pointer, and first we point to the head, okay, right here. So now while the fast is not none, also the fast.next is not none. That means we have space to move for the fast pointer, and whenever we have space to move the fast pointer, we obviously have space to move the slow pointer as well, which is only move 1 step at a time, right? And so when we get out from this while loop, the slow pointer right now is exactly the head of the second half of the linked list. So this chunk of code, what it's doing is just separating the two halves by using the two pointer method, as we discussed. Now, what we're going to do is to reverse the second half of the linked list. With the previous initialized as none. Also, the current pointer as a slow pointer is again the slow pointer right now is the head of the second half, while the current pointer is not none, and so now we have the temporary next linked list linked node to save for us to move forward, right? So I call it the next equal to the current dot next. Current dot next points to the periods. This is where we reverse the pointer. So originally the current dot next is equal to next, right? So now we reverse the direction to the periods. So essentially, the 2 was pointed to the 1, and now we reverse the 2 to point to the none, right, on the first step, because the periods right now is set as none. And now this is where we move forward, right? So periods equal to current, and also current equal to the next. This is where we move forward to the next current. Again, people keep saying do not memorize the code, but for linked list there are a lot of standard template. So either you understand it or I think the most important part is to understand and digest and have the linked list move in. I always have linked list to move in my head first before I put it on the code. So anyway, let's dive in. Let's continue. So now let's compare the two halves, right? So we have the first current and also the second current, okay? And so the first current actually is just the dummy head dot next, which is exactly why we initialize the dummy head. So this is to help us to grab the first half when we do the comparison. And also second half, when we get out from this while loop, actually the periods will be the head of the second half. So I also call it second current equal to the periods, which is actually this guy over here. And while the second current is not none, and now we're doing the number comparison, right? So if the number of the first current is not equal to the number of the second current, that means at least one number is not the same. So we break out from the while loop and then return a false. Otherwise, both of the two currents will move forward, right? When we get out from this while loop, meaning that the second current is none, and that means we compare all the numbers, all of them they are the same, so we return a true. Let's submit that. And it works. So for time complexity, it's gonna be big open. Basically, this is the first pass of the linked list, and now we have the reverse. This actually is half of the traverse of the entire linked list, and now we have the comparison, also a half of linked list. So the entire time complexity is going to be O(n), and for space complexity, we actually have not yet used any external space other than just the dummy head. So it's going to be big O(n), and yeah, so this is my solution to this problem. I hope this is helpful. If it is, please like and subscribe. Thanks so much for watching. See you next one.